Again, so this is a homework problem, number 53. Let's say a survey is conducted from a population of people of whom 35% have a college degree. The following sample data was collected for a question that asked each person, do you have a college degree? So here's our data set right here that you're given. In part A, please calculate the sample proportion of respondents who have a college degree. So the thing we're interested in counting is people who have a college degree. So what would I be counting in my data up here? What word? We're looking for all the yeses. Go ahead and count. How many yeses do you see in the data set? 9. I get 9, I think. Okay, I see a 9 in the chat. Fantastic. And for my sample, you can count all of it, or you can do 3, and it's got 10 columns, so it's 30. So we're going to be working with that 9 and divide it by 30. So someone with a calculator or good mental math, what's 9 over 30? What's our sample proportion? It's got to always be in decimal format. It's 9, right? 0.3. So that'll be our that'll be our sample population, our p bar, because it came from our sample. Here's our sample data. So now we have to go ahead and put it all together, right? So part B asks, and the homework, the wording is a little bit weird. That's why I specifically wanted to do this as an example in class so we can talk through it. What is the probability of getting a sample proportion, p bar, as extreme or more extreme than the one that you saw in part A, if the population has 35% with college degrees? And then let's talk about this in just a moment. Let's just make sure we know our P's and P bar. So what is our population proportion, or lowercase p, according to the story? So if I go back to the story on the last here, a survey is conducted from a population of people of whom 35% have a college degree. So what's my population proportion? Yep, the 35%, but we always have to put it into decimal format. So it's going to be 0.35. And then the sample proportion that you helped me solve by counting the yeses on the last screen, that's the 0.3. So really important that we know how to pull out the population proportion. Again, if you look in the story here, here's the clue. If the population has 35% college degrees, that's the information that we're looking for. So whenever you see the percentage, that's our clue, because percentages and proportions are related. They're just written differently. Okay, now the rest of the question asks if the p bar is greater than the population proportion, meaning if our sample proportion is bigger than the population proportion, then that event of interest is looking for the p bar or greater, the extreme, the right side. If our p bar is less than the population proportion, if our sample proportion is smaller or less than the population proportion, then we're going to be interested in finding the probability that p bar is less than. So we're going to be on the left side. So this is where I need to interpret. Looking at my two numbers here in blue, how does the sample proportion compare to the population proportion? Is it less than or greater than? Less than, yes. Our 0.3 is smaller than our 0.35. Therefore, we're going to be looking for an extreme scenario that our population proportion is less than or equal to 0.3. So it's going to be a less than scenario. So let's go ahead and plug in our variables in the right place. And so on the homework, this might change up because the system always changes things. So you might end up with a sample proportion that's greater than. You'd be doing a greater than scenario. If it's like this and you end up with a smaller proportion, then it would be a less than scenario. Plug it in to p bar. Take our population proportion and plug it in for the p. And then in the denominator, what goes down there? What number? The p right here, that's our population proportion. So it's helpful to look for the similar symbols. So p and p, we're going to be putting 0.35 in the denominator. And our n was the 30 from the last slide. How many yeses and nos on the same screen? So I want to make sure we see how this works. The p bar, the sample proportion, the smaller subset of information I have, that goes in first. And then the p, or the population proportion given to us in the story as a percentage, is going to go everywhere else. right? We don't see a line over this P. That means it's a population proportion. And then our N is 30. So I want you to go ahead and with a calculator, find the sampling error, take 0.3 minus 0.35. What do we get on top? What's our sampling error? What's 0.3 minus 0.35? Okay, good. That's going to be the negative 0.05. That's what's on top. And then also in your calculator, or if you're comfortable with Excel, you could type this in and I'll show it in a moment. If you want to go ahead and solve for our standard error of a proportion down here. So you do 0.35 times 1 minus 0.35 divided by 30 and then square root the whole thing. Please tell me what you get for our denominator. And this is where most errors occur, but hopefully you got it, but it's 0.0871. And let me go ahead and just show that in Excel real quick. So if you were to do it in Excel, we would do equals square root parentheses. Then you got to do all that math, right? 0.35 times parentheses 1 minus 0.35 and close that, divided by the n of 30, close out. So that's why I say if you're comfortable with Excel, you can use Excel. If you're not, use a calculator. But that's how we get the 0.087 and some change. So I'll go ahead and bring us back to the slide deck here. But when we divide these two numbers, hopefully you get what I get. Our z value is going to be negative 0.57. So just check your math, see how that worked. Let's go ahead and find the probability then. Since we're doing a less than scenario, we're going to use this formula here, right? Norm.s.dist. Remember, whenever we're doing a greater than, it's 1 minus, but we're doing a less than, so we're going to use this one right here. So go ahead and type in equals norm.s.dist, parentheses, type in negative 0.57. That's what we got when we plugged in all of our variables into this formula here. And then type in true. What do you get? So double check norm.s.dist, negative 0.57, 2843. Fantastic. Okay, so you can see here we were working with different formulas to convert our sample data into a z-value. And then we also use Excel to solve for the probability. So conceptually, we want to make sure we understand this tells us how many standard deviations away we are from the middle of the curve. And this tells us the probability of getting that sample, the probability of the shaded area, whether it's less than or greater than, depending on the scenario, or in between two numbers on our normal distribution curve.